Welcome to this weekly. We are going to focus on inequalities in this assignment. The first example says, the cost of a pack of chewing gum in a vending machine is 75 cents. The cost of a bottle of juice in the same machine is $1.25. Julia has $22 to spend on chewing gum and bottles of juice for her team, and she must buy 7 packs of chewing gum. So if B represents the number of bottles of juice, which inequality represents the maximum number of bottles that she can buy? Well, in this question, we already have our let statement if B represents the number of bottles of juice. So that's our let statement right there. And then what we're going to do is we're going to say, well, let's just write the equation, or the inequality. Sorry. So we're going to say, well, we know it's 75 cents per pack of chewing gum. So it's 0.75. And that's going to be multiplied by the number of packs of chewing gum. Okay. If I add that to the $1.25 per bottle of juice, but we don't know how many bottles of juice that we're going to purchase, so we're just going to put a bottle of juice, right? And then that's going to have to be equal to or less than 22. Because you can't spend more than $22. Now we know that we are going to be required to buy 7 packs of chewing gum, and so what we would do is insert the 7 in for the 75 cents, and it looks like our answer here is going to be choice D. All right, thanks, and stay tuned for the question. Okay, let's look at this next question. It says, a high school drama club is putting on their annual theater production. There is a maximum of 800 tickets for the show. The cost of the tickets are $6 before the day of the show and $9 on the day of the show. To meet the expenses of the show, the club must sell at least $5,000 worth of tickets. So there are 2 parts to this question. The first part says, write a system of inequalities that represents this situation. We do need a let statement here, or let statements. So what I'm going to say is number of pre-sale ticks equal, let's go with X, and then number of day of ticks equal Y. Okay, so now we need to come up with a system here. So I know that if I add X and Y together, the number of both type of ticket, I will come up with less than or equal to 800, because I cannot sell more than 800 tickets. So there's just the inequality that deals with the number of items. The next inequality will deal with the rate. So the cost of the before, or the pre-sale tickets are $6. So 6x. If I add in the 9, so it's going to be plus 9y. And this is going to be equal to or more than, because it says we are going to sell at least 5,000. So greater than or equal to 5,000. So there is our system. Okay, let's look at this next part of the question. In part B, it says the club sells 440 tickets before the day of the show. Is it possible to sell enough additional tickets on the day of the show to at least meet the expenses of the show? Justify your answer. So what I would do here is pay attention to the fact that it says these 440 tickets are pre-sale tickets, the day before the show. Let's find our maximum number of tickets that we could sell here, first of all, on the day of. So if I were to put in 440 for X pre-sale tickets, and it should be less than or equal to 800. If I subtract the 440, what this will do is it will give us Y is less than or equal to 360. That tells us that the maximum number of tickets we could sell on the day of is 360, assuming that we've pre-sold 440. Okay. Now let's do the same thing. On the flip side, though, let's figure out what is the minimum number of tickets that we could sell to still reach our goal. All right, so the other inequality comes into play here. It's still going to be our pre-sale tickets here, 440. Assuming that's how many we pre-sold, we're going to go with our plus 9y greater than or equal to 5,000. All right, so what we're going to do is multiply our 440 times, and we get 2640. So we'll write that down, 2640 plus our 9y greater than or equal to 5,000. Subtract off our 2640 from both sides. We get 9y greater than or equal to 2360. So I'll put that, oops, losing my pen here, 2360. And then divide by 9 on both sides. And y is greater than or equal to 262.3. Sorry, 262.2. Alright, so what that means now is that we can sell a minimum of 263 tickets, right? Because if we were to sell 262 tickets, you can't sell 0.2 tickets. So if you sold 262, we would not reach our 5,000. So we are going to have a answer of 263 as our minimum. And so, as long as the club sells between 263 and 360 tickets on the day of the show, they should be able to meet the expense requirements. All right, please stay tuned for the question to follow. Let's look at this next question. It says, Edith babysits for X hours a week after school at a job that pays $4 an hour. She's accepted a job that pays $8 an hour as a library assistant working Y hours a week. She'll work both jobs. She is able to work no more than 15 hours a week due to school commitments. Edith wants to earn at least $80 a week working a combination of both jobs. So using a system of inequalities, determine and state one combination of hours that will allow Edith to earn at least $80 per week while working no more than 15 hours. If we could graph this inequality on our calculator and find an ordered pair that lies in the overlapping shaded region, that would work in terms of a combination that would allow her to earn at least $80 working both jobs and not working more than 15 hours. We do need some let statements here. So let's go with X. Now this is already given to us. Babysit is X. So X equal number of babysitting hours. And then Y equals, that's already given as well, number of library hours. Now, if I were to go make an inequality here, a system of inequalities, I add my X, number of babysitting hours, and Y, number of library hours together, we should not have more than 15 hours, and so it'd be equal to or less than 15. Now also, that's just the total of the hours, by the way. Also, bringing in the rate per job, we should have 4x plus the 8y. Now, this is going to make at least 80, or she's hoping to make at least 80, so we're going to have it greater than or equal to 80. So there is our system of inequalities. Now, if we were to rewrite these inequalities in a form that we can graph, we would have y is less than or equal to negative x plus 15. This is simply isolating y. We would also have y is greater than or equal to negative 1/2 x, and it's plus 10. So, if we go over to a calculator screen, let's see. So, make sure that we can kind of see the whole thing here. All right. What you're going to do is you're going to input your two inequalities. So you have a y equals screen. Let's delete out the equal sign, and you're going to insert a less than or equal to, and then we'll put a negative x plus 15. Okay. Don't worry about the shading at this time. Control G brings back up the entry line, and we're going to, again, backspace. We're going to put in a greater than or equal to symbol now, and it's going to be negative. If you want to do Control Divide, brings up your entry line here with your text boxes for fractions. Put in your x and your plus 10. Okay, I can play around with the window here to be able to see everything. If you go into Menu and you go into Window Zoom and Windows Settings, I don't want to see a whole bunch of numbers on the the negative side of the y-axis. So let's see, I'm going to change the -2. Let's go up to like a 20 on my x-axis for positives. Again, I don't need to see a lot down here on the y-axis and the negatives. And let's try to go with like a 20 above. And there we go. So anything in this overlapping shaded region would work as a solution to this system of inequalities. All right, so let's go back to our example here. And again, as long as you can pick an ordered pair, an XY ordered pair that is in that solution set, that overlapping region, it would work as an answer for this question. Thank you, and please stay tuned to for the question that follows. Okay, let's look at this next question. It says David has 2 jobs. He earns $8 per hour babysitting his neighbor's children, and he earns $11 per hour working at the coffee shop. Write an inequality to represent the number of hours, X, babysitting, and the number of hours, Y, working at the coffee shop that David will need to work to earn a minimum of $200. Minimum right there leads me to believe, yes, it is an inequality. David works 15 hours at the coffee shop. Use the inequality to find the number of hours, full hours, he must babysit to reach his goal of $200. So it's full hours, just make sure we remember that. All right, let statements. So number of babysitting hours equal X, and then number of, let's see, coffee hours equal Y. All right, so if I take these and I come up with an inequality, it doesn't say a system of inequalities. There's not quite enough information to make a system because we don't know the total number of hours he could work. It says he does work 15 hours, but it just says to write an inequality. Okay, so I'm going to make a rate inequality. If I use my $8 per hour for babysitting and my $11 per hour working at the coffee shop, I'm trying to make a minimum of $200, and so it's equal to or greater than 200. Minimum meaning I could make more. All right. Now, on to the second part of the question. It says David worked 15 hours at the coffee shop. Coffee shop is Y, and it says to use the inequality to find the number of full hours he must babysit to reach his goal of 200. And so we're going to have 8x plus 11 times our 15 is greater than or equal to 200. And that's going to give us 8x plus 165 is greater than or equal to 200. Subtract off the 165. 8x is greater than or equal to 35. And if we divide both sides by 8, x is going to be greater than or equal to 4.375. And so it says David must work full hours here. So he has to work at least 4.375 hours. I don't think he's allowed to work partial hours, and so David must work at least, well, he must work 5 hours to reach his goal. All right, that is it. Please stay tuned for the question to follow.